जब हम इंटरव्यू वाला वेबिनार बनाया था ना, तो उसमें बहुत सारा कमेंट आया था कि भैया ठीक है, बात तो आप बना दिए कि बोलते रहना है और ऐसे ऐसे करना है, टिप्स एंड ट्रिक, लेकिन बताइए ना रियल में करते कैसे हैं। तो थंबनेल से आपको पता चल रहा होगा। तो आज मेरे साथ मेरा एक दोस्त है विवेक, जो कि सैमसंग R&D में सीनियर इंजीनियर है। उसके साथ एक मॉक इंटरव्यू करेंगे, और ये मॉक इंटरव्यू बहुत ज़रूरी है ना, क्योंकि अभी तक आप लोग को लगता है कि किसी भी इंटरव्यू में, किसी भी DSA इंटरव्यू में आपको बस जाना है, कोड कर देना है। नहीं, वो 40% काम है, बाकी का 60% आपको और चीज़ें करनी है। बात करना है, क्वेश्चन कैसे पूछना है, फॉलो अप का आंसर कैसे देते हैं, टाइम कॉम्प्लेक्सिटी कैसे समझाते हैं। बहुत ज़रूरी है कि इसको अंत तक देखिए। आपको समझ में आ जाएगा कि कोई भी बड़ी कंपनी, जैसे फैंग लेवल की कंपनी तक जिसका में आप जाना चाहते हैं ना, उसमें सिमिलर ऐसा एग्जैक्ट इंटरव्यू होता है। इससे कोई अलग चीज़ें नहीं होती है। हम भी बहुत सारे इंटरव्यू दिए हैं, बहुत सारे लिए हैं, सेम एज विवेक। तो हम दोनों जानते हैं कि इंटरव्यू में होता कैसे है, इंटरव्यू में करना क्या होता है, एक्सपेक्टेशन क्या होता है। लास्ट में हम लोग आपको कुछ फीडबैक देंगे, और हमको अगर लगेगा कि हम कुछ गलती कर दिए हैं, या उसको लगेगा कि हम कुछ गलती कर दिए हैं, तो वो बताएगा। तो पूरा इंटरव्यू देखिए और समझिए कि एग्जैक्टली क्या करना, कैसे किसी को प्रॉब्लम को अप्रोच करने से लेके लास्ट में कोड समझाने तक, ये जो पूरा जर्नी है ना, आपको 40 मिनट में कैसे कवर करना है। तो जल्दी शुरू करते हैं, चलिए।
Yush, thank you for joining.
Yeah, hi Vivek.
How have you
Am I
been?
audible?
Yeah, you're audible. How are you?
Yeah, yeah, I'm fine. Thanks.
Okay, so we'll start off with a brief introduction. I'll go first. So,
Mhm.
my name is Vivek, and I've been working in Samsung for the past 2 years. So, my work primarily includes building microservices using Java, Spring Boot, FastAPI, and all of that. So,
Mhm.
please go ahead.
Okay, so my name is Pratyush Narayan. I have done my BTech from UPS Dehradun. After my BTech, I cracked the GATE exam with 546 rank, and I went on to do my computer science MTech from IIT Dhanbad. Now, coming to my professional experience, I have around 3 years of experience. I have worked in Sandvine for the past 2.5 years, which is a deep packet inspection company. I worked in the data plane department, which develops and manages the flagship product ActiveLogic. My work there was mainly in the C language, and alongside with that, I also worked in heavy system development for the own Linux distribution Sandvine had. I also worked in NIC development in DPDK, and from the past 6 months, I've been working in Akamai, which is a CDN company. I work in the cloud data services team, which is responsible for the data processing for the compute power used by customers, which directly relates to the billables of Akamai. So it involves working with a large scale of logs generated by the edge workers and our team processing them. My work here is primarily in C++ with a slight focus on system level programming and the Perl. So yeah, this was all about me with a brief summary of my educational and professional background.
Okay, thank you for your introduction.
Yeah.
So, I'll explain you in uh, a bit that what this round is going to be about.
Okay.
So we'll be dealing with problem solving in this round. It will be a
Hmm.
session of around 40-45 minutes, close to 40-45 minutes.
Hmm.
And I'll throw a question at you.
Hmm.
And I will be looking at how you approach that question and whether you're able to narrow down to a decent optimal solution. All right, sounds good?
Okay. Yeah.
Okay, so we'll dive straight into the question.
Okay.
So
So do you want
you,
me to share my screen?
yes, please do so.
Okay. So can I use VS Code for coding?
Yeah, sure.
Okay. Yeah.
Okay. So you have an array of integers, all right?
Okay.
And what I want to do is I want you to find out the number of subarrays
Okay.
that have a cost which is either equal to k or less than k.
Okay. So this K is an input.
K is an input.
Okay.
Okay. So you have the array and you have k.
Okay.
All right. So
Hmm.
you have to give me the count of the number of subarrays which have a
Hmm.
cost less than equal to k. So
Okay.
coming to the definition of cost, by
Hmm.
cost of a subarray, I mean the maximum element of that subarray minus the minimum element
Okay.
multiplied by the length of that subarray.
Okay. Got it. Length of subarray. And this subarray can be like any length subarray, like a variable length subarray.
It can be any
And
length subarray, yes.
okay. So okay. So just that I understand the question, I'll repeat the question and
Okay.
you tell me if I'm going wrong. So the input will be an array of integers and a k, which is a number. My output should be number of subarrays, which their cost should be less than equal to k, and the cost is in that particular subarray. It can be any length subarray. The maximum element in this subarray and minus the minimum element into the length of that subarray.
Correct, correct, correct.
Okay. Okay. So may I know the constraints? So what will be the length of the array? Maximum.
So let's say the length of the array will go up to 10 power 5.
Okay. And may I know what is the constraint of the k?
So k can go up to 10 power 15.
Okay. Very, very huge. And what about the elements of the array?
The array elements, let's say, will go up to 10 power 9.
Okay. Got it. Okay, so elements can go up to 10 to power 9 and the length can be 10 to power 5. So this cost can also go up to 10 to power 15, let's say, around that range.
Okay.
Okay.
You have
So
any further
now,
clarifications about the question?
no, I think I got the question. I'll start thinking about the question and I'll discuss the approaches which are coming to my mind.
Okay, sure.
So, uh, so there are many parts to this question. First is we have to take a subarray. Then we have to maintain the max of that subarray. And then we have to maintain a min of that subarray. And then we have to compute the cost. And let's say if that cost is, let's say, less than equal to n, means it is the valid subarray, then we have to add to our answer. Okay.
Correct.
So see, the first approach which comes to my mind is the brute force. So how will I solve it in brute force if I have no idea? That the first thing I'm thinking is, so the length of subarray, first of all, this length of subarray which is in the cost field, this can range from, I don't think we can take an empty subarray, right? Subarray needs to have at least one element.
No. It has to
So,
be at least length 1.
so then it can range from 1 to n, which n being the length of the array. Now, for each of these functions, I'll call each of these lengths, I'll call a function. What it will do is, it will be like a fixed window kind of thing. So fixed window means fixed subarray of this length, for example, of length x. Length x. So what I'll do is I'll loop over each of these fixed subarrays. Inside each of these fixed arrays, I'll loop to find the min and max. Now I'll find the cost. And if that cost is less than equal to k, then I'll increment my answer. And this I'll repeat for every length from 1 to n. So this whole process I'll repeat for every length from 1 to n. Now,
can you walk me through the time complexity for this?
Yes. So first of all, the main thing is this: the length is 1 to n. So this itself will be order of n. So this itself is order of n. Okay. Now this function is fixed window length of x. So on an average, the fixed window size also takes up order of n. But we are also looping to find the min and max. So this will also have an n complexity. Now the overall time complexity will become somewhere till n cube. And the space complexity will be order of n. Order of 1, sorry. We are not using any space. So the space will be order of 1. I would not like to go ahead with this approach because obviously n cube will not work with this constraints at all.
All right.
So yeah, so I will try to optimize this brute force. So now naturally when I say this question of sub arrays and questions involving number of sub arrays, I tend towards sliding window approach, which will be a variable size sliding window approach. Now, why I'm thinking sliding window is sliding window needs to have a condition where we have a very valid and fixed logic when to expand and when to shrink. Okay. Now, let's say I have a particular window from low to high. It can be any length window, and if the cost is less than k, it means it is a valid window.
Okay.
In this case, I would like to expand it. Why I'm saying that I'll expand is this. The cost is maximum minus minimum into length of subarray. So when I expand, two things can happen. Either the max can change the max will become a new element. The new element will become the max, or the min will change. So new element will become min. So two things can happen. So max can increase, or the min can decrease. And obviously, if I expand, the length will increase. So
Mhm.
there is no way that if you expand the window, your cost will ever decrease. Expanding the window will always increase your cost. So
Okay.
if I have a valid window, if the cost is less than k, then I can expand to see till where I can stretch the window. Similarly, when the cost is more, let's say when the cost is more than k, it means we have come into an invalid window. In this case,
Mhm.
expanding won't help. Expanding will just keep increasing the cost. So we'll just go into more and more wrong. So sliding window, the goal of sliding window is if the result is good, you have to keep expanding and find the best result you can. But if the result has become bad, then you have to make the result good before proceeding further. So in this case, I would like to shrink the window, which will bring down the cost.
Okay. Okay.
So this is why I think sliding window can be used here, because we have a very tight logic when to expand, when to shrink.
Mhm. But I don't understand one thing. How do you plan on counting the subarrays?
Okay. So how do I plan on counting the subarrays? So let's say in the beginning we have low is equal to 0 and high is equal to 0. Now, when we include high is equal to 0, when we include high is equal to 0, we find that our result is good. It means the cost is less than equal to k.
Okay. Okay.
Now, how will I count? So my goal is to count the number of subarrays, not the length or not anything.
Mhm.
So this I is equal to 0 has to be included in the result. Now,
Okay.
initially, how many subarrays were there? Initially, there was there were 0 subarrays total, because we have just begun.
Mhm. Mhm.
So this high is equal to 0 will have to be get added to those subarrays. So how many subarrays are ending with high? I'll count that as of now. When I have low is equal to 0, high is equal to 0, it means this window is valid. How many
Mhm.
subarrays will end with 0? So there is only one subarray, which is 0 itself. That will come from high minus low plus 1. I would like to give a separate example. So let's say my low is equal to 2 and my high is equal to 5. 5.
Mhm.
How will I count this? So I'll count that whole window is valid. 2 to 5 whole window is valid. How many
Okay.
subarrays will be like ending with 5? So there will be one is 5, one is 4 and 5, one is 3,
Mhm.
4, 5, and one is 2,
Mhm.
3, 4, 5. So ending with 5, there are 4 subarrays. So I have to add 4 to my result. That will come again from high minus low plus 1, which is 5 minus 2 plus 1. That's why I'm always adding high minus low plus 1, because at every high which tells me that this result is valid, I'm calculating how many subarrays are possible which are ending at high. So that will come from this particular formula.
Okay, but I have a question here.
Mhm.
So you started off by saying that the array from low to high, which is 2 to 5, is valid, correct?
Yeah,
Correct. So, and now you started building new subarrays with 5, 4, 5, 3, 4, 5. So I understand that
correct,
2, 3, 4, 5 is valid. But how can you
correct.
be so sure that even 3, 4, 5 is valid, even 4, 5 is valid? Because I saw that 2, 3, 4, 5 is valid. I'm
Okay.
not sure if 3, 4, 5 is valid.
Okay. So let's say, if I understand your question, it's like 2, 3, 4, 5 is valid. How am I sure that 3, 4, 5 is also is valid?
Correct.
So let's say in 2, 3, 4, 5, uh, the cost is, let's say, 100, which is valid, which is
Mm-hmm.
less than k. Now, when we come to 3, 4, 5, now 3, 4, 5 is nothing but shrinking 2, 3, 4, 5.
Mm-hmm.
Okay. We have already established that when we shrink, our cost decreases. When we shrink, the cost can't increase. That's why we are shrinking in the first place when the cost becomes more than k. When we
Okay.
expand, the cost will increase. When we shrink,
Mm-hmm.
cost will either remain same or it can shrink. Two things can happen. So when
Okay.
you come to 3, 4, 5, cost can be less than equal to 100. Cost can't become 110 in 3, 4, 5. That is not possible, because shrinking can't increase your cost.
Okay.
So let's say the cost is 90, which is still less than equal to k, because if 100 is less than k and this cost is less than 100, then obviously cost will be less than 90. So this will also be valid. Similar is with 4, 5. If you have 2, 3, 4, 5 as valid and you shrink you remove 2, you remove 3. 4, 5 will also be valid because 4, 5 cannot have a cost more than 2, 3, 4, 5. Cost can only increase when you expand, right?
Okay.
So that's why I'm
Sounds
so
good.
sure, and that's why every high I'm just adding the high to this set of subarrays.
Okay.
Okay.
So do you want to code this down?
Yes. So now I have one more problem. I've only solved the first problem, which is the variable size window. I have one more problem, which is how well I maintain the running min and running max.
Okay.
So if it was a frequency kind of thing, I would have used an unordered map. But to maintain the running min and running max, what I would like to use is I would like to use an ordered map here. Why I'm saying ordered map is because if I use unordered map will not have the keys in sorted order. So first of all, I'm planning to use a map which has key as the element and frequency as the value.
Okay.
Now, how I'm planning to use this map to my advantage is, let's say at any given moment, let's say my low is equal to 0 and my high is equal to 2. I have already, let's assume that I have processed this. And my map looks like this. My map looks like, let's say there is 2, which has appeared one time. There is 3, which has appeared one time. And there is 4. Sorry, there is 4, which has also appeared one time. So my map looks like this. Now I want to include a new element, which is I is equal to 3 in the map. First
Okay.
of all, what I'll do is, let's say array of high in this case is 5. I want to include this new element in my window. First of all, I'll include this element in my map. So my map will become this. Because this is an ordered map, it will be sorted according to the keys. Keys are elements. Now, what do I want? Now my window has become low is equal to 0 and high is equal to 3. So 4 elements. In this 4 element, I want two things. I want the min and I want the max. Now, if the map is already sorted, and I take out the first entry from the map, the first key from the map, it will automatically give me the min. Also, if I take the last entry of the map and I take the key, it will automatically give me max. So I don't have to do too much because the map is already taking care of my min and my max.
Okay.
So this way I'll maintain a running. Same thing will happen when I shrink the map. So when I shrink the map, let's suppose I shrink the map and I do low is equal to 0 to low is equal to 1. What will happen is this will get removed. Still, my maps first is giving me the minimum and my maps last is giving me the maximum. Whatever the internal sorting and all happens, I think in C++, a map uses a balanced BST or a red-black tree. I'm not sure about Java, but yeah, so that will balance itself.
Okay.
So
And
this is going to be
do
my
you know how much time
approach.
it takes to balance that?
Yes. So assuming it's a AVL tree or a red-black tree, it should take about order of map size time, not more than that. Sorry, order of log map size time.
Okay.
So it should not take more than that because it's a balanced BST or something like that. So it should not take more than log map size. And extracting the elements, extracting the first and last element will be order of 1. It will be same as unordered map.
Okay. All right.
So this is my approach, and I would like to go ahead with this approach as of now.
Okay. Before you start coding, I'd like you to run your logic against a small test case. Is that okay?
Yes, that's absolutely okay.
You can take
can
the
I write the pseudocode first? Just
Okay,
the
sure.
steps.
Go ahead. Yeah,
So I
sure.
can be clear what to run. So I'll just write the function if that's okay.
Yeah, please.
So I'm assuming I'll get a vector and I'll get a key.
Correct.
I know the constraint of k is this, so I have to take long log, but I'll fix that when I get to it. Okay, so this is the size. I need two things. First of all, I need a map. Sorry, not in unordered. I need a simple map, which is int and int. So this will do two things. This will do the elements and the frequency. Now for sliding window, I have a template with me. So I always start with high is equal to 0. And for the result is 0. So I'll follow my template. So the expanding, I let the for loop do my expanding. I don't care about the expanding myself. Whenever I come to a new high, first of all, I include this high in my window. What including means is f of array of high plus plus. So now this is included. Now I have to take a cost. Now let me write a helper function to find the cost. Now helper function any day I'll pass the map, and it will give me the cost of that particular map. Now
Okay.
in the helper function I'll do two things. So first I'll do an auto IT max. So it's a little different in I think little, and I'll take a new iterator which is auto min is equal to it should be previous of f dot end. Why I'm doing the previous and end is because when you do f dot end, you reach the end of the hash map, which is not to any particular entry. When you come to previous, then you reach the last element. Now,
So
if I
does
want
begin
the
give you the max or min?
no, oh sorry, yes, begin gives me the min, my mistake, and this gives me the max. Correct. Last gives me the max. Now let me first find the min-num. Min-num will be it min dot first, because we are interested in the keys. And similarly, if I do a maxnum, it will be it max dot first. Yes. Now okay, I should have also passed the low and high. Why I'm passing the low and high is for the length. Now
Okay.
in cost is equal to it will be maxnum minus minnum into the length of this particular window will be high minus low plus 1. And I'll just return this cost. So this is my helper for the cost. Now, while I've included this high, so let me find the cost very quickly. So helper, and I'll pass the map. I'll pass the low and high. Okay. Okay. Now in sliding window, I like to do is sliding window. Our theory was if the result is good, it's okay. We have to note down the result and keep on expanding. But if the result is bad, we have to shrink. So let me, while my result is bad, while my the result bad will be while my cost is greater than k. So this will signify my result is bad. So my result or my window is bad. So shrink. How I'll shrink is, first of all, we have to start shrinking from the low. So first of all, remove this array of low from the map. And if, for example, if our map contains a frequency, if the frequency becomes 0, then we have to erase it from the map because it won't automatically happen. Why I'm erasing is because if we have a 0 thing, if we have something like this in our thing, so it means that 2 is not at all present in our window. But if you query the first, it will still give you 2. So which will lead to wrong answers. That's why I'm erasing this.
Okay.
After this, I'll just do low plus plus, and because the whole cost, this cost is dependent on map, it is dependent on low, and it is dependent on high. In this shrinking, we are changing low and we are also changing the state of the map. So we have to calculate this again. We can't rely on the previous value here.
Okay.
So
Okay.
otherwise, this will fail. So this was this, but we have changed the map and we have changed the low, and cost is directly dependent on both of these. So we have to again compute. Now, when we come here, the window is good. It means whatever the window is, some low to some high, it is good. And we'll just do res plus equal to whatever we discussed, high minus low plus 1. It means how many sub-arrays are ending with high. And at the end, I'll just return res. So this will be my pseudocode. Do you want me to run it against any input?
Yes, please go ahead against.
Okay.
So the array contains 1, 3, 2.
1 second. The array contains 1, 3, 2. Okay. And what is k?
And k is 4.
Okay. Okay. So I'll have this as my map. Sorry. So initially my map is nothing. I'll have low is equal to 0 initially, high is equal to 0 initially, and I'll also have a result is equal to 0 initially. Okay. So let's begin. High is equal to 0. Now, first of all, what we do is we include this element in our map. So 1 becomes 1. Now, what will be the min is the min will be 1 and the max will be 1. Our
Okay.
cost will be 0 because min and max are equal. So cost is 0, cost is better than k. So this is a correct window, so no need to shrink. We'll just do res is equal to res plus high minus low plus 1, which is 0 minus 0 plus 1. So res becomes 1. We'll go
Alright.
ahead.
Alright.
Now high is 1. High is 1 means, first of all, include this 3 in your map. Okay. Now my min is still 1, but my max has become 3. And my cost is 3 minus 1, which is 2, into the length of the subarray, which is now 2, is equal to 4, which is still good. It is still less than equal to k. Okay. Now again, I'll add in my result 1 minus 0 plus 1. So 1 plus 2, which is 3. Moving ahead, we come to 2. When we come to 2, our map becomes 2, 1. Okay. Now the min is 1 and the max is 3, but the size of the subarray has become 3. So my cost has become 6, which is not good. So I have to shrink now. So let's start shrinking. First of all, shrink low is equal to 0. Low is equal to 0 means, first of all, we'll decrease the frequency. And because this has become 0, I'll remove it from the map. After shrinking, let's compute the cost again. So my min has become 2 and my max has become 3. Now my new cost will become 3 minus 2, which is 1, into 3. 1 into 3, which will be 3. Sorry, I have to also increase the low. So my length of the subarray has now become 2. So this is 2. 2 is better than 4. So I'll stop shrinking. So as of now, my low is equal to 1 and my high is equal to 2. Now again, I'll add in my what do I say in my result, which is high minus low plus 1. So high minus low plus 1 is 2 minus 1 plus 1, which will be 2. And in my result, I'll add that 2, which will become 5. So my final answer will be, I think, 5.
Okay, 5 is correct. 5 is correct.
Yes, even if we trace out the subarrays, it will become one subarray is 1. 1 is 1 and 3. 1 is 3. 1 is 2. And 1 is 3 and 2.
Alright,
So
that
these
is
are
fine.
the,
I understand that. Can you
yes.
just walk me through what happens if k is 0?
What happens if k is 0? Okay. Now, so every cost should be less than equal to 0. Can cost ever be 0? Cost can be 0 when min is equal to max? Yes. Min is equal to max, then it can be 0. When can min be equal to max is if if all the if all the elements are same in the subarray, then you can achieve a cost is equal to 0. So first of all, single length subarrays are definitely the answer.
Okay.
So the answer is, sorry, so the answer is definitely more than n, because every element in itself is an answer because it will give a cost of 0.
Okay.
Now, whatever in any subarray, if the min is max, that is also be 0. So, okay, so if any subarray has all the elements at same, the cost will be 0. Otherwise, the cost will be definitely more than that. So yeah, I cannot think of any special case. Still, we have to solve it because there can be subarrays which have same elements in them, right?
Okay. That is what I was looking at. That is, all the elements should be equal in that subarray. Okay.
Correct. Yes, but still we have to run the code. We can't say that answer will be definitely more than n. I think, in
Okay.
fact, any answer we have is going to be more than n because every single element can be an answer if the k is not negative.
Correct.
And if the k is negative, there can be no answer because you can't have any subarray which has a negative answer. It can't be possible.
Okay. I think this is a decent solution for this question, and
Okay.
it should work given the constants and the data structures that we have used. I'd like to understand the time complexity and space complexity of your solution.
Sure. So let's start with the space complexity, which is easy. So I'm using a map, which is having an int. Worst case, you never need to shrink, and you will have every element in your map. So worst come to worst, you can have an order of n space. Well, 2n, but
Okay.
yeah, order of n space.
Okay.
Now coming to the time complexity. Let's see. In our program, we have one main loop, which is this.
Mm-hmm.
So this will run n times. Okay. Now, in the loop, we have one is helper. Is helper taking any helper? This is also constant. This is also constant. Everything is constant. So helper is a constant function. Helper doesn't take any time at all. So helper is okay.
Okay.
But in the help, okay, sorry. But in the helper, yes, this line where we are increasing in the map, this will take an order of log n time because we are
Okay.
inserting something in the map. And similarly, this line will also take a order of log n time because we are deleting something from the map.
Okay.
Now, in the sliding window, let's see how many times. So I have identified there are two statements. One is this login and one is this login. Rest everything is constant. How many times at worst can we insert an element? So in sliding window, because the low cannot be more than high, we will also always have a window where low is less than high. So every element will get a chance to be inserted once. So this will run at max n times. Similarly, if an element is inserted, it can only be extracted out once because if we shrink an element, even if we pass an index, there is no way that we are going to shrink that again. So this statement also will be run at max n times. So at max, every element will be enqueued in the map once, dequeued from the map once. So
Okay.
I think at worst, the time complexity is going to be order of n log n because of the sliding window. Because every element will have a chance to get in once and get out once in the worst case possible.
You pointed out two lines where you think the complexity shoots up to log n, which is plus plus and minus minus, right?
Uh, yes, correct.
How about f dot erase? What is the time complexity to delete an element from map?
Okay, yes. Correct. I missed that. This will also be login. Correct.
Okay.
Any
Mhm.
changes we are doing in the map contents will have a login complexity. Correct.
Okay. Okay. So this is n log n, right?
Yes.
Okay. Can you think of a better? I mean, this should work given the constants,
Mhm.
but can you think of a better solution to find the min and max? Something better than log n.
Better solution to find the min and max. Okay. Uh, one
I
data
mean, you
structure
have
I
the
was
liberty. Mhm.
one data structure I was thinking about was heap, but I did not go with heap because heap will behave the same as map and it will increase the space. So initially, what I was thinking is we can have a heap. So we can have two heaps actually. We can have a
Okay.
min heap and a max heap. It will behave as the same way as map. So instead of maintaining one map from where we can get the minimum and maximum, we'll have two heaps where we can get the minimum and maximum, but the heap will behave the same way. The insertion and deletion in the heaps will also cost us log n. So heap
Mhm.
will not help much. It will increase the space. That's why I went with map in the first place.
Okay. Okay.
But I've done questions where we maintain a running minimum and maximum by using a DQ, especially a monotonic DQ.
Okay.
So what I'm thinking was it would be a little complex, but I'll have two DQs. So
Mhm.
one DQ for which is monotonically increasing, and one DQ which will be monotonically decreasing. Now, what will happen
Okay.
is the one which is monotonically increasing, the front will give us the maximum, sorry, minimum.
Okay.
And the one which is monotonically decreasing, the front will should give us the maximum.
Okay.
Because and whatever we are doing here, we are including this thing and result. Same thing we'll do in DQ, but to maintain the monotonic property, we'll insert from the back, and it will because the DQ1 is monotonically increasing, we'll try to insert from the back, and it will pop out all the smaller elements than it has. So naturally, the minimum travels through the front. Similarly, in the monotonically decreasing DQ, whatever elements are greater than it, it will pop them from the DQ, remove them from the back, and naturally the maximum will travel to the front. And all these operations will cost us order of one because DQ does not take time. At max, all elements can be pushed in DQ once, all element can be popped in DQ once. So the time complexity will boil down to order of n, not n log n, because we eliminate the extra log n operations that we are doing in map and heaps by using DQs.
So
But
I
it will be a
understood
little
the min max
complex.
part,
Yes.
but how do you keep trace of the window?
How do I keep trace of the window?
Like as in, how do you make sure that the min and max which are being generated from the DQs, they
Mhm.
are a part of a valid window?
Okay. They are part of a valid window. Okay. So see, let's come down to the insertion first. So let's say I'll run this the same way we did for maps. So let's say this is my DQ1, which is monotonic increasing, and I'll have my DQ2, which is mono decreasing. Okay. Now let's say I want to insert one. So any insert I'll do in both of them. So this is like a very easy. I'll insert one in both. You will get the minimum as one, maximum as one. Okay.
Okay.
Now let's say I want to insert three. Now in this monotonically increasing DQ, I can just insert three because it maintains the monotonic. It doesn't need to pop anything. But in the
Okay.
monotonic decreasing, three will come and three will pop this one off.
Mm-hmm.
Now three will at the front. Again, when
Mm-hmm.
you query the front of the DQ1, you will get minimum as one. Query the front of DQ2, you'll get the maximum as 3. Everything all right. But if you want to, let's say, do this 2. Let's say we do this. What 2 will do is 2 will pop 3 because it needs to satisfy the property of monotonic increasing. What 2 will do is 2 will just come here because it's all right. Still, you're getting the minimum, you're getting the maximum. But now, let's say we want to shrink and we want to remove 1. Now, anytime while removing, we'll check in the DQ1 that if the front element is not 1, then we don't need to do anything. But if the front element is 1, we'll pop out 1. If the front element, why I'm saying we only need to check the front element is, uh, if the element is not at front. So we already know that 1, 3, and 2 are pushed into the DQ. Surely we are pushing the DQ. But if they are not present in the front, it means that someone has popped them. So that's why we don't need to take care. In the DQ2, we do not find 1 in the front, so we don't do anything. So now you see we have removed 1 and still we have a valid window which is 3 and 2. If you take out the minimum, you will get 2. If you take out the maximum, you will get 3 and you will stop there. So this is what I was thinking on a rough basis.
Okay. Makes sense. Okay.
Yeah, and all of this will be order of 1. So we'll need to use 2 DQs and the insertion will be a little complex, not too complex. But yes, the time will boil down to order of n. It can be done till order of n. There is no way to do it less than n.
Okay. I think we
Yeah.
have discussed pretty much all aspects of this question,
Mhm.
and I think the solution works. So, yeah, thank you for your time.
टाइट क्वेश्चन करते हैं, कर दिए ना सॉल्व. मेरा गलती बता दो तो, अरे ये भी यूट्यूब पे जाएगा, सो गए हो. मेरा चलो बता दो तो.
अरे वो
स्टूडेंट्स को
बताना भूल गए, वो वेरिएबल वाला, वेरिएबल का नेमिंग एफ लिख दिए थे.
हाँ 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 हाँ, हाँ, बता दो, ये भी यूट्यूब पे जाएगा. तो
ठीक है, रुक जाओ, लिख कर
बता
रखे
दो
थे
तो
हम
क्या
कुछ
क्या
कुछ तो.
फीडबैक है.
हाँ, पहला फीडबैक ये था कि जब मैंने पूछा था कि जब विंडो श्रिंक करोगे तो ये कैसे मेक श्योर करोगे कि करंट विंडो जो है वो वैलिड है, तो आई वाज लुकिंग फॉर अ बेटर इंट्यूशन कि अगर हो सकता है कि मेरा जो एलिमेंट हट रहा है विंडो से, वो अगर मिन है तो
हाँ
मेरा
हाँ,
नेक्स्ट मिन तो इससे बड़ा ही होगा, इससे छोटा तो नहीं हो
ठीक है,
सकता,
ठीक है.
है
हाँ
ना.
हाँ हाँ.
तो आई वाज लुकिंग फॉर दैट. दूसरा है कि वेरिएबल का नेमिंग तुमने, मैं आपको एफ कुछ तो लिख दिया था, अजीब अजीब सा नाम.
हाँ, वो
फिर
सब देखिए नहीं करिएगा, वो सब एकदम नहीं करिएगा. वेरिएबल का नेम हमेशा
और
अच्छा होना चाहिए, तुम कर दिए लेकिन.
फिर कुछ सिंटैक्स इश्यूज थे, बट आई गेस सूडो कोड में तो चलता है वो, तो ठीक है. बाकी तो आई गेस
हाँ,
कि अच्छा ही था.
तो देखिए यही आप लोगों को करना है. हम बोलते हैं ना कि लगातार बात, इंटरव्यू में अगर 30 सेकंड से ज्यादा का चुप ही हो जाएगा ना, तो फिर बहुत गंदा लगता है. 30 सेकंड चुप रहना मतलब एकदम खराब हो जाएगा, इंटरव्यू खत्म हो जाएगा. जब 30 सेकंड अगर घड़ी पे गिन लिए ना कि चुप हो गए, तो बस इंटरव्यू फिर खत्म है. फिर वो भी मोबाइल चलाने लगेगा, बोलेगा कि यहाँ जाओ यार, जो लिखना है लिखो, कुछ भी लिख दो, जो मन कर रहा है वही करो ना, ब्रूट ही लिख दो. चुप नहीं रहना है, कुछ ना कुछ बोलते रहो, बकवास बोलते रहो, कुछ ना कुछ बोलते रहो, उसको क्वेश्चन समझा दो 2 बार. तो ये सब बोलते रहो, बाकी तो बहुत परफेक्ट इंटरव्यू था. इसलिए वो करते हैं। ठीक है, हम सबको और फीडबैक भी दे देंगे। और कोई
ठीक है।
फीडबैक नहीं ना है तुम्हारा? देख लो, सब लोग, बच्चे लोग देख लीजिए, असली इंटरव्यू ऐसा ही होता है, ठीक है? अगर आप लोग इसी कंपनी में जाएंगे तो एग्जैक्टली इसी तरीके का इंटरव्यू होगा, इससे अलग नहीं होता है। और इंग्लिश वगैरह बोलना सीख लीजिए, इंग्लिश अगर नहीं भी आता है तो सीख लीजिए, काम लायक आना चाहिए, बहुत परफेक्ट नहीं, लेकिन आप बोलेंगे कि हिंदी में नहीं हो सकता है क्या, तो जो इंटरव्यू हो रहा था उसी को हिंदी नहीं आता होगा तो क्या करिएगा? इंग्लिश आना चाहिए, इतना आना चाहिए कि आप जो सोच रहे हो बोल तो सको कम से कम इंग्लिश में। इंग्लिश में ज्यादा वो सब नहीं करना होता है, ठीक है? तो ठीक
अच्छा।
है, आप लोग को अगर अच्छा लगा हो तो कमेंट करिएगा, और आगे वाले सेशंस में हम लोग सोच रहे हैं कि आप में से किसी को उठा के इंटरव्यू लेंगे, पेशाब निकालेंगे बुला के जूम पे। ठीक है।